Welcome back from break. We are continuing with our trigonometry, but we're going to look at solving word problems today using angle of elevation and also angle of depression. All right, let's start with angle of elevation. When looking up to an object, the angle of elevation is formed by an observer's line of sight and a horizontal line. You can see in this picture, right, we've got a person and they are looking up at an object. It happens to be a lighthouse. So that's the line of sight. And if from their eyesight, then we draw a horizontal line, we create this angle, and that's your angle of elevation. That angle of elevation, or this triangle that gets made, is not always elevated off the ground. And as we work through some of these problems, you'll see that that angle of elevation can actually be on the ground. Okay, so, excuse me. For all of these, we're going to draw and label a picture. Then we're going to solve it using our trigonometry. And then, of course, our rounding rule, they're asking us to round to the 10th place. So for the first one, it says Casey sights the top of an 84-foot lighthouse at an angle of elevation of 58 degrees. Casey is 6 feet tall. How far is he standing from the base of the lighthouse? So this picture up here actually goes with this first problem. So we know that the whole lighthouse, the whole thing, is 84 feet. The angle of elevation is 58 degrees, and that Casey is 6 feet tall. So the question is, how far is he standing from the base of the lighthouse, which actually means we want this distance here, which is the same as the horizontal distance up here. So that's where we'll put our X. Now, the triangle we're working with, though, is just this part. So I'm going to draw that down here. So we know we have 58 degrees. That's our missing part. But we need to know this length right here. And that is not the whole lighthouse. Okay, it is the whole lighthouse minus this part right here, which we know is 6 feet as well. So if we subtract 84 minus 6, we're going to get 78 feet. And that's what we're going to use to solve our problem. With respect to our angle, the 78 is opposite, and our missing part is the adjacent. So we would be using tangent. So we would write tangent of our degree, 58 degrees equals, and tangent is always opposite over adjacent, so 78 over X. As you were solving last week, I hope it kind of became obvious that to solve for X, you're either multiplying, right, or you are dividing. When X, your variable, lands in the denominator and we go to cross multiply, you're going to end up dividing the numerator, 78, by the trig function. All right, because I would start with X times tangent of 58 equals 78, and then I would divide by the tangent. So I'm hoping that you guys, I told you before 3 steps, right? Step 1 is to show me the equation. Step 2 is then to solve it. So this is the work that you need to show. And then step 3, we actually punch that into the calculator and we'll get 48.7. And then of course, you're going to write a very quick sentence that asks how far is he standing from the base of the lighthouse. So we would write, Casey is standing 48.7 feet from the lighthouse. Okay. And one thing this sentence, of course, allows us and reminds us to do is to put the proper units on our answers. Okay, number 2. All right, the angle of elevation from a kicker's foot on the football field to the top of the goalpost bars is 17 degrees. If he's standing 131 feet from the base of the goalpost, how tall is the goalpost? So again, here's that phrase, angle of elevation, which simply means that we are on the ground or something's on the ground and it's looking or going up. So we've got our field goal. All right. Here's the top of the goalpost, that part right there. Kicker's down here. And from his foot up to that, we had an angle of elevation of 17 degrees. All right, he is standing 131 feet from the base, so that would be down here along our horizontal. And the question is, how tall then is the goalpost? So there's your right triangle. Again, the 17 across from that is the opposite, so that's our missing part, and the 131 is our adjacent. So again, we're doing tangent of our degree equals, and this time the x is in the numerator, x over 131. Always opposite over adjacent. So when we cross multiply this time to get x, we're going to multiply 131 times the tangent of 17, and then that gives us 40.1. All right, how tall is the goalpost? So very quickly, the goalpost is 40.1 feet tall. All right, remember you can always pause, slow me down if I'm going a little too fast. All right, Leah's mom standing at the bottom of the slide at the playground waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top is 46 degrees and the slide has a vertical height of 9 feet, find the length of the slide. All right, so here's Leah's mom standing at the bottom of the slide. All right, the angle of elevation from the bottom to the top is 46 degrees. The slide has a vertical height, so up and down, of 9 feet. Find the length of the slide. So this time, we're finding that part, which would be our hypotenuse. So the missing part is the hypotenuse, and across from that would be the opposite. So this time we're using sine. Sine of your degree is always opposite over hypotenuse. All right, again, x is in the denominator. So what I'm ultimately going to end up doing is the 9 divided by the sine of 46 degrees. And that gives us 12.5. So quick sentence, right? The length of the slide is 12.5 feet. All right, and our last angle of elevation problem. Dog is standing 5 feet from the base of a tree, looking up at a cat that has climbed 16 feet up the tree. What is the angle of elevation from the point the dog is standing on the ground to the cat? All right, so we've got a tree, got a kitty cat up here. Down here, we've got a dog. All right, so the dog is standing 5 feet from the base of the tree, so the 5 goes there, looking up at the cat, who has climbed 16 feet up into the tree. So the cat's 16 feet up. What's the angle of elevation? So x this time is the angle measure, but we label and figure out which trig function to do the same way. So across from that angle, the 16 is opposite, 5 is adjacent. So we've got, once again, the tangent, but this time the x goes where the degree measure usually goes. So the tangent of x degrees equals opposite over adjacent. Remember, this is the work you want to show. So to solve for x, what you're going to type in the calculator is the inverse of the tangent, and then type in 16 over the 5. All right, and when we type that in, we get 72.6, and that will be a degree. And then the question is, what is the angle of elevation from the point the dog is standing on the ground to the cat? So the angle of elevation from, don't just tell me, give me a little bit of detail here, from the point the dog is standing to the cat is 72.6 degrees. All right, so again, angle of elevation, when you see that phrase, simply means that you are on the ground or near the ground, but looking up at an object of some kind. Okay. Angle of depression. Put my paper up. All right. Says when looking down to an object, the angle of depression is formed by an observer's line of sight and a horizontal line. So this time you're up, so you'll notice this person sitting up on this chair. So their line of sight is going down towards the ground. And then there'll be a horizontal. So the angle of depression is up here. The triangle, though, is down here. All right, that's what we're going to be working with. So it goes on to say the angle of depression is going to be congruent to the angle of elevation because they are alternate interior angles. So this dotted horizontal line would be parallel to the ground. So the angle of depression and this, what was the angle of elevation, are always going to be the same. Okay, so whatever they tell us is the angle of depression, we're going to put it down here in our picture. All right. Again, we want to draw pictures, solve, and round to the 10th place. Number 5, a lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? So this picture is already drawn for us. Let's label. All right. The lifeguard's line of sight is 8 feet above the ground. Now, this is the line of sight, but this is the above the ground. All right. That's not, they didn't give us the length of the line of sight, but they told us how far he was above the ground. So that's the 8 feet. The angle of depression is 18 degrees. So if that would be 18 degrees, then down here, our angle of elevation is 18 degrees. And the question is, how far away is the swimmer from the lifeguard? They're not talking this distance. All right, the swimmer, if I told him to go to the lifeguard, he would swim along the horizontal. So this is the distance that they're asking for. All right, so if we look at that triangle separate, we've got 8x and then 18 in the corner. So 8 would be opposite that angle, x is adjacent. So we would be doing tangent of 18 degrees would equal 8 over x. Cross multiply, and to solve for x, we would end up doing 8 divided by the tangent of 18 degrees. And that would end up being, calculator, 48, no, wrong one. All right. Sorry, had all these answers. How about 24.6? There we go, 24.6. So our sentence, how far away is the swimmer from the lifeguard? The swimmer is 24.6 feet away from the lifeguard. All right, number 6. The pilot in a helicopter spots a landing pad below. If the angle of depression is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude of the helicopter? All right, so let's draw a little helicopter here. We got a pilot inside. He spots a landing that's down here. All right, the angle of depression, which would be up here, is going to be the same down here. The horizontal distance to the pad, the horizontal distance right here is 1,200 feet. What's the altitude? So it's asking for that height. So again, we've got opposite and adjacent. So we're doing tangent of 73 degrees equals x over 1,200. So this time we will multiply 1200 times the tangent of 73 degrees. And we would get 3,925. Now it rounds to 0.0, and we want to keep that because that reminds us that this was rounded. That's not an exact 3,925. So we're going to still round to the tenths place. Now, these are our notes. I'm going to start cutting corners here, and we would write a sentence and make sure that we put the proper units on there, which would be feet. All right. We want to just make sure we get pictures and the work that should be done. Number 7, we have building A is 480 feet tall, building B is 654 feet tall. If the angle of depression from the top of building B to the top of building A is 42 feet, how far apart are the buildings? All right, so we've got building A is 480 feet, and then building B, which is taller, is 654 feet. The angle of depression from the top of building B to the top of building A is 42 degrees. So notice here's a right triangle. Here would be my angle of depression. So that's going to be the same in there. How far apart are the buildings? So it's asking for this distance right here. That's our missing part. So we need to know this distance right here. Very similar to the lighthouse problem for angle of elevation, right? That height is not the whole height of building B or the height of building A. We need to subtract these two. And when we do, we get 174. So this is really the triangle that we're working with right here. So again, we've got opposite, adjacent. So the tangent of 42 degrees would equal 174 over x. We would do 174 divided by tangent of 42 to get our right answer, which would end up being 193.2 feet. And then you would write your sentence. All right, and then our final. Zach is standing at the top of a lookout tower and spots a water fountain below. All right, so here's our tower. Here's the fountain. So that means he's looking down. The lookout tower is 75 feet. The angle of depression, which would be right here, and right here, these would be the same, is 28 degrees. What is the horizontal distance between Zach and the water fountain? Horizontal distance is down here. So again, we're working with opposite and adjacent. A lot of times we are working with tangent with word problems, and the reason for that is because it is easiest to actually measure vertical and horizontal lengths and heights more so than it is these diagonal heights or lengths. All right, so that's why most of the time you will see tangent being used, but it's not a hard rule, so don't think it always will be. All right, x is going to end up being 75 divided by the tangent of 28 since our variable's in the denominator, and we end up with 141.1 feet. And you would write a sentence to finish up. Okay. Hopefully that was enough examples to help you out. So it's now time to practice. Come and see me if you need any help with any of the problems.